For these particular problems, it's probably a lot easier if you are able to turn them into mixed radicals first. So we have root 500 over root 27. The root 500 can be broken down, that's 100 times 5. Same with the 27, that can be broken down, that's going to be 9 times 3. This gives us a couple of perfect squares. On the top, 100 is a perfect square, it can be brought out, that's now a 10. The 9 can be brought out, that's a perfect square, and now it's a 3 on the outside. So what you're left with is 10 root 5 over 3 root 3. We cannot have a radical in the denominator, so we have to get rid of it. That's what we're going to focus on, is that root 3. So we're going to times both the top and the bottom by root 3 to get rid of it. On the top, you have 10, and you're going to multiply the radicands together. That's 5 times 3, that's going to be root 15. On the bottom, you multiply the radicands together. You got root 3 times by root 3, that's just going to be 3. And of course, you're going to multiply by that coefficient, which is 3. Working this one out, you've got 10 root 15, and on the bottom, you should have 9. And I don't think you can reduce this any further, so that's your final answer. With B, you've got 3 root 240 all over root 108. 240 can be broken up, that's going to be 16 times 15, and 108 can be broken up, that's 36 times 3. 16 is a perfect square, that can be brought out, so now that's a 4, and that's going to multiply that coefficient on the outside. 36 is a perfect square, that's going to be brought out, and now that's a 6. So what you're left with is 12 root 15 all over 6 root 3. Now, of course, we could rationalize the denominator here. If you take a look at the radicals, 15 is divisible by 3, so we can do that instead. So 12 divided by 6, that's going to be 2. 15 divided by 3 is going to be 5. So your answer is 2 root 5.